Hello, good morning, my dear students. Hope so you all are fine and enjoying these digital classes nowadays. Welcome to chemistry period. We are doing unit 2 solution, and today in continuation that we have started for yesterday, colligative properties. And as we know that now colligative word come from two letter, that is co mean together and ligate mean to bind. So it become together to bind. All those properties of solution which depend only on the number of solute particle, not on nature of solute particle. Okay, so all those solution in which the number of solute particles is going to be make the property that is called colligative properties. So basically solvent and non-volatile solute. We have discussed two type of solute: volatile, non-volatile. Volatile solutes are in which liquid is going to be mixed with liquid, means solute is liquid and solvent is also liquid. That kind of solution is called volatile solution. And in which solid is which is a general solution we have in our daily life. Solid, when solid is going to be mixed with the liquid solvent, then it is called non-volatile solute. Okay, so basically non-volatile solute is forming four different type of properties. The first property is vapor pressure, so it is going to be lower when as comparison to its pure solvent. Elevation in boiling point is going to be increased as we studied yesterday. Depression in freezing point, it is opposite to this. So hope so you understood all these three properties. So today our focus is on fourth property, that is called osmosis and osmotic pressure. Dear students, although especially medical students, although they discuss this osmosis topic in biology also, we discussed this in 9th class also. So the word is not that much new for you. This is very much reliable and very much familiar to you. So what is the meaning of osmosis? Osmosis is the phenomenon of flow of solvent molecule through a semi-permeable membrane molecules from pure solvent to solution. In a simple word, sometimes what is happening, you have seen, I think, when we are putting a potato inside the water. So what is happening? The potato is swell up. After some time you can see potato's size is becoming a little bit bigger, large. And same potato when we are putting under the sunlight, okay, then you will see those potatoes are going to be shrink very soon. Or like you can take example of tomato, you can take example of without shell egg. So there are so many examples. Even in our body, the blood cell is also going to be swell and going to be shrink. That process is called osmosis. And the osmosis word we are using especially when it is going through a semi-permeable membrane. Without semi-permeable membrane, then it is called diffusion. Okay, so now the pressure which is created by osmosis, that is called osmotic pressure obviously, but the definition is osmotic pressure of a solution is the excess pressure that must applied to a solution to prevent osmosis. It is the pressure of a solution excess pressure that must be applied to a solution, means solution side. Solvent is creating pressure toward solution side and it stops the flow of solution towards solvent. That pressure is called osmotic pressure. It is denoted with pi, and pi is equal to W2 into RT upon Vm2. So this value we need to find out, okay, through a derivation. So for example, to stop the passage of solvent molecule through a semi-permeable membrane into the solution, it is the meaning of same. So osmotic pressure is proportional to the molarity at given temperature. So molarity is written here in the form of C because of concentration. So pi is directly proportional to C, so become pi C RT, where RT is the constant gas law. Okay, so C is N2 upon V, mean N2 is mole upon B, volume. So N2, as we know already, it is W2 upon M2. N2 is the solvent, the mole of solvent. When we are finding it, we will find it by given mass upon molar mass. The formula is there. So given mass upon molar mass. The one mass will be given in the numerical. Molar mass you need to calculate. So when we'll compile all these equations with this value, the value become pi. In place of C, we will write now W2 upon M2. So it becomes pi is equal to W2 upon M2 and RT upon V. Okay, because in place of this we will write this. So V will remain. So in place of, by putting all these values, this will become W2 upon M2 upon V. Okay, so this C is going to be replaced here. So the equation become pi is equal to W2 RT into upon Vm2. So when we are finding M2, as we are finding in every case the molarity, So when we are finding this molarity, so then W2 upon RT upon V, this pi will replace with M2, so V into pi. So you can, by replacing, reshuffling the equation, you can find out both the equation. Okay, so now dear students, some of the numerical is coming related to this, but before going to numerical, let's discuss some example of osmosis with the help of this book. So this value we've now already determined. So it is the measurement of osmotic pressure provided another method of determining molar mass of solute. This method is widely used to determine molar mass of protein, polymer and other macromolecule in our that biochemical process. So there are some advantages of osmotic pressure. Before going to advantages, let's talk about example. A raw mango placed in a concentrated salt solution loses water. That is called osmosis and shrivel into the pickle. Raw mango, when the kacha raw mango we are placed in the concentrated salt to make the pickle. So we can see the osmosis process somewhere, because that is going to be shrink. Built flour reveal when placed in a fresh water through osmosis. This also you have seen. The carrot that has become limp because of water loss into the atmosphere can be placed into water, making it form. We are doing some of the vegetables like carrot, cucumber. These when going to be shrink, then we are putting it in the water. After some time you can see that is getting its own original size. That is because of it is gaining all the concentration of water from outside to inside. So through osmosis, blood cell collapse due to loss of water when placed in water containing more than 0.9% salt solution. This question is sometime asking, like in reasoning way, why our blood cell collapse due to loss of water. Why blood cell is collapsed due to osmosis? Then you have to write, because the water containing more than 0.9% salt solution, then only it will collapse. As next is people taking a lot of salt and salty water food experience water retention in tissue cell and intercellular spaces because of osmosis. This result puffiness and swelling is called edema process. Edema is a kind of disease in which the body is going to be swelling. Next is water movement from soil into the plant roots and subsequently into upper portion of the plant, partially due to osmosis. So like this way, the preservation of meat also we can do by salting and of fruit by adding sugar. Protect against bacterial action through the process of osmosis. A bacterium on salted meat or sugar fruit loses water and shrivel and dies. Okay, so this is these are the examples of osmosis. Now some of the advantages of osmosis is there. The osmotic pressure's advantages. The osmotic pressure method has an advantage over other method as pressure measurement is around the room temperature and the molarity of the solution is used instead of molarity. Mean the osmotic pressure method has the advantage over the method as a pressure measurement is around the room temperature and the molarity of the solution is used instead of molality. Because of this, as you know that already, the molarity of the solution is used instead of molarity because of it is independent to temperature. As compared to other colligative properties, its magnitude is large even for very dilute solution. The technique of osmotic pressure for the determination of molar mass of solute is particularly useful for biomolecule as they are generally not stable at high temperature and polymer have poor solubility. Yes, it is used. These colligative properties having advantages than other three colligative properties, because this technique of osmotic pressure for determining the molar mass of solute is particularly useful for biomolecule and polymer. Why? Because in biomolecule it is generally not stable at high temperature, but this osmotic pressure can. Polymer have a poor solubility osmotic pressure, which is measured by Barclay and Hartley method. Okay, classes. So thanks for watching this video. Once again, I'm going to appeal you just to break this chain of coronavirus. Stay home, stay safe, don't go out of your home, and just think about your families and yourself. Okay, so thank you, have a nice day. Thank you.